So when manipulating a statement that includes a conditional statement, there are three types of conditional comparisons. There is the contrapositive, um, there's the converse, and the negation. And what these three represent are if the original statement was P implies Q. So let's say P implies Q. Then the contrapositive of that is not Q implies not P. Let me write that out. Not Q implies not P. The converse of that statement is Q implies P. Q implies P. So right away we realize that the if and only if statement, P implies if and only if, or P if and only if Q, is the statement and its converse, because it's P implies Q and Q implies P, which is this. So that's where the converse is useful. And then the negation. P, not P, that's one we have to write out. Not P implies Q is the same thing as not P or Q, which is the same thing as P and not Q. So you see you have a lot of different options to use when dealing with a negation, which comes in handy especially when well, the more options you have, I think, the better, because it gives you a wider range of tools to work with. But anyways, we'll focus on our task at hand. So what we're going to do is we're going to compare the truth tables to these statements to see what they are in comparison to the original statement. So P and Q, we have P is true, true, false, false. Q is true, false, true, false. P implies Q is only false when the mom lies after the kid does his homework. So it's only false here. Everywhere else is true, true, true. Now, not Q is the opposite of this row right here. So not Q is false, true, false, true. Not P, the opposite of that row, is false, false, true, true. False implies false. That's false. Kid does his homework. Mom doesn't give him what he wants. Give him his reward. That's false. Kid does not do his homework. Mom's not a liar. Kid does his homework, gets what he wants. Everybody's happy. So true, false, true, true. That is the same as the original statement. So the contrapositive is equal to the original. Now the converse, Q implies P, which is just the same in the opposite direction. Let's see, Q, we have right here. Whoa. There we go. Q implies P. Cut, paste. So Q implies P. True implies true. That's true. Kid doesn't do his homework, still gets ice cream. Mom's not a liar. Kid does his homework, doesn't get ice cream. Mom's a liar. Kid doesn't do his homework. Doesn't matter what mom does. So true, true, false, true. We see this is not the same as the original statement, because that's, maybe I should highlight this. The original statement is true, false, true, true. The next statement is true, false, true, true, which is the same. But this statement, oops, is not the same. True, true, false, true. Now let's compare the negation. So we can pick any one of these, and let me actually just give us a little bit more space to work with. There we go. Oh well. Alright, now P and not Q. So we know P, we can get those truth values from here. Not Q, well, we already made a truth table for not Q, so we can just steal that from over here. Ignore that green line. We can probably get rid of that. And P and not Q. So let's evaluate this. We'll make it yellow. P and not Q. True and false. So we know that an and statement is true only when both are true. So this is the only true we have here. This is false, this is false, and this is false. We see that this truth value doesn't have anything to do with the other ones unless we look at it from an opposite perspective. True, false, true, true is the opposite of false, true, false, false. So the negation, as you may well have guessed, is just the opposite of the original, which is also the opposite of the contrapositive. So let's just let's clear some space here. So we know the converse. The converse is not equivalent to the original, and the negation is opposite. To the original. And those are the three comparison functions.